All right, so here's a quick demonstration on how to use the TI-83 calculators with linear regression. Now, the main thing to keep in mind is that there's lots of different places where linear regression sort of shows up in the calculator. Let me make the screen a little bit larger so you can see it a bit better on screen. But the different places are all under the Stat menu. And then if you go under Calc, you'll see a linear regression function. And if you scroll down a bit, there's another one that says linreg b plus ax. But neither of these are going to do exactly what we want. So you want to make sure you go over to the Tests submenu, because in this class we're always going to be doing hypothesis tests with correlation and linear regression. And so here, you do have to scroll down a bit, but you'll find the function that you need to use for this class, and that is linreg t-test. All right, so let's go through a full example, see how it all works. Okay, so this is a pretty common example. We have two sets of data. One set of data is an independent variable, the other one is a dependent variable. The independent variable here is weekly cardio in minutes, so the amount spent exercising by a group of random people, and their resting heart rate listed, at that next particular day. Okay, so we have to, the weekly cardio is our independent variable, and so we have to put that data into a list. So we'll begin there. We'll come over here to our list editor and just start entering this data into a list. So the independent variable, which is usually labeled with an X in most of your homework problems, goes into L1. And so we have 110 and 90. And then your Y data is going to go into the other list here, L2. And that'll be a standard throughout the class, so don't worry about changing that at all. All right, once that data is in, then you can go and do linear regression. All right, so as I said, what you'll need to do is under the Stat menu, go over to Tests, scroll down, and eventually you will get to linreg t-test. Now, linreg t-test, you don't have to do anything special for. It will just simply do all that you need. So if I run that, it will ask me where my X data and Y data is. So you put that in L1 and L2 by default. Frequencies, you should just always have that set to 1. This beta and rho input value here, these are hypothesis tests. So it's asking for your alternative hypothesis symbol, and that's either a not equals, a less than, or a greater than. In fact, in our case, though, it will always be a not equals. So we'll just leave it there. The regression equation, you can just leave blank and then hit calculate. So you really just need L1, L2, not equals to 0. Then we run, and we get a lot of information here. So the first thing that's important is a p-value. So that p-value is 0.039. Let me go ahead and jot that down. So we have a p-value of 0.039. And then we have a couple of different values, a and b, which are important. And these are the coefficients for our linear regression line. And the line of regression is of the form y equals ax plus b. It kind of tells us up here at the top. And so we just substitute these values. So this would be 78.12 times x and minus 0.19. Oh, actually, my bad. This is a plus bx. So this is the slope. So negative 1.9 times x. Let me fix that. Negative 0.19 times x. And then a is the y-intercept, so plus 78.12. Okay, then the next things here, we have the value of S, which we don't need. You just keep scrolling down, and eventually you'll get to this value R. So R equals negative 0.833. So R equals negative 0.833. So this is our correlation coefficient, and that will always be asked in these questions. You're trying to get a correlation coefficient that's pretty close to 1 in order to say that there is a good line that fits this data pretty well. And then that tells you that this line of regression over here is a good fit, so it can be used for predicting. But it's hard to tell exactly how close to 1 that correlation coefficient really needs to be, so this p-value kind of tells you as a hypothesis test just how close that needs to be. So if you're doing like a 5% level of significance in this case, then the p-value would be less than the level of significance. So you would reject the null hypothesis, and the null hypothesis is that there is no statistically significant correlation. All right, but that's how you use the TI-83 here.